This is a dam, 126 meters, straight down. Drop a basketball off the top, and it does exactly what you expect. Now drop a second ball from the same spot. Same ball, same height, same air, same gravity. This one lands 16 meters away. Nothing pushed it. Nobody threw it. The only difference is that the second ball was spinning, so it's the spin. Except spin by itself does nothing at all. There is no sideways force hiding inside a rotating object. Here's the experiment that settles it. Run the same drop, same spin, with the air taken away. It falls dead straight. Not nearly straight. Zero sideways movement. Put the air back, and 16 meters of curve returns. So the spin was never pushing the ball. The spin was doing something to the air. So let's go and look at the air. Sit on the ball and watch it stream past. The surface of the ball is moving too. On this side, the skin is turning with the oncoming air. On this side, it's turning straight into it. And air is sticky. It grips the surface and gets dragged along with it. So on one side, the flow is pulled faster, and on the other, it's held back. Solve the flow exactly, and the fast side is moving nearly 3 times the speed of the slow side. Now here is the step everyone skips. Faster air has lower pressure, which means the air is now pressing harder on one side of this ball than the other. Add that pressure up all the way around the surface, and it does not cancel. There is a force left over, and it points sideways. Now turn the picture upright. That is your falling basketball, and sideways is exactly where it went. So how hard does the air actually push? For a basketball turning 5 times a second, the sideways force peaks at about 1/5 of the ball's own weight. 1/5, held sideways, for 7 full seconds of falling. That is what 16 meters is made of. And it scales with the spin. 2 turns a second, 6 meters out. 4 turns, 13. 8 turns, and the ball lands 26 meters from the wall. Same ball, same drop, only the spin changed. And this is not a trick that only works off dams. Strike a football at 38 meters per second, with 14 turns of side spin. And over the 35 meters to the goal, it bends 5 meters sideways. That is enough to leave the boot outside the wall and finish inside the post. A curveball leaves the hand at 1800 revolutions a minute and crosses the plate a foot away from where a spinless pitch would. Same force, same reason. Every one of those curves is a pressure difference you cannot see. Nothing invisible pushed that basketball. The air did. It always does. You just can't see it happening.